Okay, in this presentation, I want to give an overview of what is a large language model in a technical term, but a simple technical term, something that, like a business folks can understand it, especially that ChatGPT is a large language model, and these days everybody is familiar with ChatGPT and already, have experience with that. Let's just start with some familiar business terms, some terms that we use in a day-to-day operation, and implicitly AI shaping some of the results of these operations, such as doing search, recommendation, using, for example, digital assistant, analysis, doing any kind of a categorization, matching, or prediction. All these terms, we are all familiar with it, and they are all using AI, some implicit and some even explicit one. Also, let's just look at some familiar sources of data. All of these data, all the data that we have coming from either text, like a search, web, and so on, coming from images and videos, if you have any photo, or if you, all the YouTube, basically videos and so on and so forth, coming from voice, like a spoken voice, coming from other than spoken voice, other like audios such as music, or other sources, coming from, for example, any signals that we get from nature or devices, any like sensors and so on. Also coming from unnatural languages, languages such as programming language, such as math, or even emoji, or that kind of stuff. So these are typical sources that we get our data from. Okay, one important concept, technical concept in machine learning is called embedding. I call it vectorized so we can remember it better. So the idea is that we can turn any data from any source. So for example, all the text, image, voice, and so on. We can turn any data into a vector using, for example, a large language model. So this model, has basically a network that receive these inputs and then turn them into a vector. So for example, a text finally ended up to be a series of number. So we call it this vector. Why? Because machine actually understand vector much better than any other form of data, and can do all kind of a manipulation with it. It can measure the distance between these vectors. So for example, if you have a query, it knows which document is closer to that query, for example, for a search or similarity and so on. Or it can do operation with these vectors. So for example, if I give an image to it, that image is a vector, then also a concept of aging is actually another vector in that. So you can give an input as an image as an input and ask the model to display a corresponding image, for example, when that person is aged. This is with the assumption that we already trained this model, so understand what the age means. So for example, this is a model, take the input and return us an age instances of the same image. So this is very important, because when we talk about that we can now combine all these information together, or we can talk about, we can find similar images, for your question, or for example, similar music or something like that. This is all understandable if you know that these are all turned into a vector. So So another concept called fine-tuning, which is some sort of a training, but mainly for large language models. So by fine-tuning, it means that the original language model vector is actually trained so it can predict the next word. So for example, you give series of words, and then you expect that it continues that, And because it, for example, learn from language or the other from English or other languages, in a way it knows the concepts in these languages because it can predict it pretty well. However, that doesn't stop you to train the same model for specific applications. So for example, you can train it specifically for search or recommendation or any one of these application. You can continue this training such that, for example, let's say you want to categorize these texts based on a semantic analysis. You want to be sure that all the legal terms are closer together. Or for example, you can figure out whether the customer is happy or not happy or something like that. This is all means that I start with the embedding of large language model and just continue the training specifically to get these, basically kind of application. And not only that, you can also train it for a specific more or less industry. You can do it for shopping, for entertainment, for finance, legal, or science. So in a way, now you have a matrix of different applications and different industries, and then create, for example, a ChatGPT or a GPT model or a language model for search in e-commerce or search in entertainment, recommendation, for example, in finance, maybe categorization in legal, or, for example, prediction in science, or so on and so forth. So in a way, you can start with some foundation model and fine-tune it. By fine-tune means that you don't start the training from scratch. You start the training from the embedding of a large language model, but just add, more data to it to be specialized in question answering, semantic analysis, information extraction, even image capturing, and so on and so forth. So for example, one of these models is called BERT, is a language model, but we also have something called legal BERT, which is the BERT specialized in legal, for example, in understanding legal corpus. Another concept that you probably heard is called prompt engineering, which with the introduction of ChatGPT, it's all over the web. Or I call it like in-context inference. So the idea is that you don't fine-tune the model, you use the same model which is, trained for, the large language model without any fine-tuning. However, you introduce a context to it. So in a way, you're saying that in the embedding word, so this is the embedding, I want you to search only on subset of it. So you specify a subset of that, and you expect the result from that subset. So for example, when I introduced that formally write a 500-word essay about AI, focusing on its effort on business, that means that I want ChatGPT to not search in entire space, rather to search on something which is related to AI, something which is related to business, and also, limit the result into 500 words. So you understand all of that. Or for example, you can say, give me a domain idea like techbriefy.com, because it understands techbriefy.com. It's already, crawled the web, so I understand that, with keywords in it and explain the purpose of the site. ChatGPT understands all these stuff. They all, represent some sort of a vector. So it knows that it should actually search through, a combination of these vectors, a domain which actually all these vectors, something closer to all these different vectors. tech briefing, purpose, keywords, and so on and so forth. So again, you can also do kind of an operation with that. So for example, you can say rewrite this statement or this paragraph in a legal, technical, and professional language. That means that take a vector and then just move it to another domain and tell me what's the corresponding vector on that domain. So this is all operation with the vector without fine-tuning. Or for example, you can give, this is a comparison of different monitors, but you can say that this is completely, a technical statement. You can say that, rewrite this in a style of Emily Dixon. And as you can see, it takes that technical statement and turn it into more like a, like a story or literature or something like that. So for example, if in Google you search for who is Armstrong, you probably see the image and information about Neil Armstrong, an astronaut who went to moon. However, if you have a model who is trained or fine-tuned, for music, or you give a context and talk about music and ask this question, then the model knows that you're talking about music and talk about and display, for example, Louis Armstrong, which is one of the influential figure in jazz. So in a way, the vector Armstrong in that model is closer to this picture, is closer, for example, to this article, the history of music, or even is closer to the video by Ezra Collective Band. On the other hand, if that model is not fine-tuned for music, then you may see it's closer to NASA talking about the SpaceX or the picture of going to the moon. The same thing applies if this model is either fine-tuned or have a context, so relating to legal firms. In a legal firms, then Armstrong may refer to a firm, or may refer to one of your basically staff people, or related to an article which talking about how a law firm doing that, even though there's no mention of Armstrong here, but because this is related to for example a firm, this model actually may show up. This article may show up. So in a way, this lets you to create a subset of vectors and then specialize for a specific application, such that when you query that, when you ask a question, you know that the answer is in that context and not very generic. And that's how we basically design the system, such that we can include in context or even private information, because this model stays private in the response of the model. So to wrap it up, I hope that with this video you have a better understanding of 3 technical terms. What is embedding, turning this information into vector? What is fine-tuning, changing this vector for a specific application, such as search recommendation or even specific industries? And what is prompt engineering? That means that limiting the search in a subspace of those vector space. And then how, using these 3 with a large language model, we can turn all these data into basically a specific application in a much faster and cost-effective way than just, for example, developing detailed rules and so on and so forth. Thank you.